Let us see another example in which we have to decide the order of integration. So the question is, evaluate the double integral over the region R for the function x sine of y dA. Okay, now here again dA is mentioned. So we need to decide what will be the order of integration, dx dy or dy dx. Now the region R is bounded by xy plane. X varies from 0 to cos y and y varies from 0 to pi. So now we have to check what will be the order of integration. Unlike previous question, here as x, the limit of x is in terms of y, which is a variable, we cannot select any order of integration. Okay, this has happened only when we are dealing with the rectangles, means the limit of x and the limit of y are constant. Okay, so now what we can see, the limit of x is in terms of y, so it means we should integrate x before we integrate y. So the order of integration should be dy dx. Or you can understand in another way, like we need to select the order of integration dA. So the variable which is having the constant limits, y is the variable which is having constant limits, it has to be integrated at the end. Whereas x, its lower limit is 0, which is constant, but the upper limit is a variable, cos of y, so it has to be evaluated first. I hope it's clear. Then we can rewrite this integral as double integral x sine of y. Now order of integration dx dy. Now how do we write the limit? Since the limit of x is for the inner integral, x varies from 0 to cos y, 0, and here cosine of y, and the limit for y is the outer one, which is from 0 to pi. And then we will integrate as usual. So we will start with this inner integral. Okay, so what is this? Let's write it down separately. So integral 0 to cosine of y x sine of y dx. Now you don't have to worry about this limit in terms of variable. Just follow the regular process. Now we are integrating with x. This is a function of x to be integrated, and this total is one function only. So what we will get? Integral of x power 2 over 2 sine of y, and limits for x is from 0 to cosine of y. So this gives you, in place of x, first we replace it by cos of y square divided by 2 multiply by sine of y, minus, when we replace x by 0, it will become 0. So we left with this term, cos square y power 2 over 2 sine of y. What we can see here, we finished integration with x and substituted the limits, so no x term. So it means we are doing fine. So let's write it down here. We left with the outer integral 0 to pi. The value of this integral is this term, which is cos of y power 2 divide 2 times sine of y, and this dy. Okay, now we have to integrate it. How do we integrate? So if we look at here, we have product of two terms, sine of y and cosine of y and power 2. So it means it cannot be done directly. Now we have to look whether it is integration by parts or by substitution. So let's look at it. For sine of y, we have direct rule of integration. But if we look at this term, for cosine of y, we have direct rule. But when power 2 comes, we don't have direct rule. So in this case, we will use integration by substitution. And what we will substitute? We substitute cosine of y as u, so that this term will become u and power 2. So let's do the substitution portion. We select u as cosine of y. Now, since we are integrating with respect to y, differentiate here with respect to y. We have to follow the same concept as we do for variable x. So derivative of cos of y is sine of y. Now what we want the value of dy, which will be du over sine of y, which is dy. Now substitute the value of u and dy in the given integral. So what you will get? Integral. In place of cosine y, we are replacing u. So this is u power, we didn't change. Sine of y kept same. In place of dy, we are writing this value du divide sine of y. It should be noted that as we are converting the variable y into u, here we should not see two different variables. So simplify it before moving to the next step. So we can cancel sine with sine. So what we left with here? Integral u power 2 du, whose integral is u power 3 over 3. Okay. Now back substitute the value of u as cosine of y. So this gives you cosine of y power 3 over 3. Now what were the limits? 0 to pi, where y varies from 0 to pi. Now substitute. When you replace y by pi, you get cosine of pi over 3, and power is 3, minus cosine of 0 power 3 over 3. If you use calculator and calculate the value of cos of pi, it comes out to be minus 1. You have to keep your calculator in radians mode. Okay, so it gives you minus 1. Minus 1 to the power 3 gives you minus 1 over 3. And cosine of 0 gives you value 0. Minus 1 over 3. Which gives you the final answer as minus 2 over 3.